Today we're going to talk about the mole, and the mole is a unit of measurement that represents an amount. You probably know a lot more about it in terms of a dozen, and a dozen is something that would be a lot more familiar to you. And of course a dozen means 12. 12 eggs are in a dozen, 12 slices of bread are in a dozen, you name it, there's 12 in a dozen. So the first problem we're going to do is a conversion problem, and we're going to convert from 3.5 dozen to a number of roses. So we're going to try and figure out how many roses are in 3.5 dozen. So what I'm going to do is I'm going to cancel out my units. So because I want dozen to go away, I will put dozen on the bottom. And I'm trying to get from dozen to roses. And as long as I know that conversion, I can make that happen. Of course, 1 dozen has 12 roses in it. So then we just multiply all the way across, which gives us 42 roses. That's a problem you probably could have done without me showing you the conversion for it, but it's a problem that you want to be able to do using these mole conversions. And we're going to take that and we're going to put it in terms of Avogadro's number, which is talking about a mole. 6.02 times 10 to the 23rd is 1 mole, and we'll talk about why we picked that number in a few minutes. But we're going to do the same conversion that we just did, and instead of using dozen, we are going to use mole. So I'll set up my conversion 3.5 mole, and I'll be converting from mole to my number of roses, or number of particles is the way we'll call it in a few minutes. 1 mole has 6.02 times 10 to the 23rd roses in it. So then we'll make sure the units that we wanted to cancel out do. Mole is on top and on bottom, so I'll be left with roses. And my number of roses will be 2.107 times 10 to the 24th. If we write that whole thing out, that number looks like this. Okay, that is a ginormous number. There's probably not even that many roses on the planet. So we have to think about why on earth would we want a number that big? Mole is used to measure particles, and of course particles and atoms are really, really tiny things. So we want to be able to make big things like people and dogs and you name it. So it's going to take a lot of particles to do that, which is why we need such a ginormous number. So that's what a mole is. Now we're going to talk about some of the ways we use a mole. And the first way we are going to talk about this is in terms of molar mass. So the first question is, why do we use this number? And we said that it's because the number represents something that's really, really large, but it's even more specific than that. When we are talking about an atom, let's take a look at a carbon atom. The mass of 1 carbon atom is 12 AMU, or atomic mass units. That's the number of protons and the number of neutrons added up, and that's how we got 12. Well, now let's talk about 1 mole of carbon, or 6.02 times 10 to the 23rd atoms of carbon. Those just happen to weigh 12 grams. That's why we use this number as the molar mass, because for every atom, we can convert from 1 atom to 6.02 times 10 to the 23rd atoms, and use the same number right there, which is really, really helpful. So when we're calculating molar mass, if we just have 1 atom, it's going to be the same number. But of course, not everything is as simple as an atom, so we talk about things in terms of compounds. So these are going to be notes on how to write the, or to figure out the molar mass for a compound. So first thing you want to do is write your element. Then you're going to write the quantity of that element. Remember that subscripts will distribute to all of the elements in parentheses. Then you'll multiply by the atomic mass, and then you will add up all the numbers to get that molar mass. So I'm going to give you a problem here, and the problem that we're going to do today is ZnNO3 2. So we're going to find the molar mass of this substance. The first thing you're going to do is write down each element. So I'll write zinc, nitrogen, and oxygen. That is all of step 1. Step 2 is to write down the quantity, and you have to remember that subscripts like this 2 will distribute to everything inside. So for zinc you have 1, nitrogen there's 2, and oxygen there are 6. So that's step 2. Step 3 is to go back and multiply by the atomic mass. So I'll use the periodic table to find the atomic mass. The mass of zinc is 65 grams. The mass of nitrogen is 14 grams. And the mass of oxygen is 16 grams. And I'm going to multiply those numbers out. That's step 3. And then finally, to get step number 4, we are going to add all of those numbers up. That's 189. And my units here for molar mass are grams per mole. And that's how you calculate the molar mass of a substance. So I'll give you an example to try on your own. And the example is find the molar mass of sodium carbonate. So the first thing that you need to do when you try this problem on your own is you need to find out what sodium carbonate really is. Sodium ion is positive, so it's +1, and carbonate is CO3 minus 2. Since these are bonded ionically, you'll need to crisscross. So Na2CO3 is your formula. Then you'll take that formula and you'll calculate its molar mass. So in order to do that, you'll have sodium, carbon, and oxygen. There are 2 sodiums, 1 carbon, and 3 oxygens. The mass of sodium is 23 grams. The mass of carbon is 12 grams. And the mass of oxygen is 16 grams. You multiply them all out to get 46, 12, and 48. And then you'll add them all up to get your molar mass, which is 106, and our units are grams per mole, because there are 106 grams of sodium carbonate in 1 mole of sodium carbonate. And that's it on molar mass. If you want to learn about how to convert with moles, then you'll need to watch the next video.